Hello friends, this is Nagaraj here and welcome back once again for learning the design and analysis algorithms. So in this session we'll move to the next experiment, that is write a program to obtain the topological ordering of vertices in a given diagram. And in the previous session we saw that how quick sort and merge sort works for sorting an array elements. So here in this we'll be moving to the next experiment. So here it is a program based on topological ordering of vertices which are given in a graph. That is, so we have to understand what is topological ordering, right? So topological sorting is nothing but it is for directed acyclic graph, that is DAG, is a linear ordering of vertices such that for every directed edge UV, vertex U comes before V in the ordering. So the topological sorting for a graph is not possible if the graph is not a DAG, that is if graph is not a directed acyclic graph. For example, so this is the example I have taken here, that is this is a graph, this is a given graph. Then what is the topological sorting of this graph is, that is 5, that is 5, then 4, then 2, then 3, then 1, then 0. This is one topological sorting of this given graph. There can be more than one topological sorting for a graph. For example, the another topological sorting for this given graph is, that is 4 5 4 5, then 2 3 1 0. This is another topological sorting of this given graph. The first vertex in topological sorting is always a vertex with in degree as 0, that is a vertex with no incoming edges. That is what a topological sorting is. So topological sorting, if you compare with the depth first search traversal, topological sorting traversal was depth first uh, traversal, then that is DFS. In DFS what we do, we print a vertex and then recursively call DFS for its adjacent vertices. Whereas in topological sorting we need to print a vertex before its adjacent vertices. For example, as I have shown here in the given graph, the vertex 5 should be printed before vertex 0, but unlike DFS, the vertex 4 should also be printed before vertex 0, that is 4 and 5. It should be printed before vertex 0, that is this 0. So topological sorting is different from DFS. For example, a DFS of the shown graph is, so if you are writing the DFS traversal, if you are applying DFS for this given graph is, the ordering will become like 5 2, then 3 1, then 0, then finally 4. But it is not a topological sorting. So that is the reason we are applying here topological sorting for finding the topological ordering of vertices in a given graph. Then you may ask how to get the topological sorting, topological ordering of vertices in a given diagram. So we have to follow an algorithm to find topological sorting, and that is nothing but topological sorting algorithm. But first I would like to recommend you that we have to see the implementation of DFS. So we can modify DFS to find topological sorting of a graph. In DFS we start from a vertex, we first print it and then recursively call DFS for its adjacent vertices. Whereas in topological sorting we use a temporary stack and we don't print the vertex immediately. So we first recursively call topological sorting for all its adjacent vertices, then push it to a stack, and then finally print contents of stack. And one more thing you have to note here, that a vertex is pushed to stack only when all of its adjacent vertices are already in stack. So this is how the topological sorting algorithm works. So let me code for this problem definition, and let me explain you how this topological sorting algorithm can be implemented with the help of C programming. So we are writing a C program here for this problem definition. So let me go for the coding thing. So I'll be writing the code for this. So here we have to write. So just a minute, let me clear this graph here. So the code is like this: hash include stdio.h as usual, then hash define. I'm creating a constant here with the help of hash define function, that is max equal to 20. That is a constant. We can use that constant throughout our program. So next we have here, that is I'm going to consider some array and some variables, array variable and some normal variables, that is a of max, it is a two-dimensional array, then comma n, that is to uh, ask user to enter the number of vertices. So then I'm going to declare here one method, that is topological sort. So I'm going to call this topological sort, topological underscore sort, topological sort. So this is my method I'm going to use in my program. So after that, and we have to declare this globally. So I'll be declaring them outside the main function. So these two declarations I have declared outside the main function. So then I'm going to write declaring the main method as void. The return type of the main method is void. So then we have here some local variables of this main method ij, that is for loops. Then I'm going to ask the user how many vertices in a directed acyclic graph it should have. So for that I'm going to ask user enter the number of vertices, number of vertices. Then I'm going to read this value with the help of address of n with the help of scanf statement. It is scanf percentage d, because it is an integer number, it will be identified by percentage d that it is an integer. So address of n will be read with the help of this scanf statement. Then printf, then enter the adjacency matrix, enter slash n, then enter the adjacency matrix. So what is adjacency matrix, right? Adjacency matrix, that as I told you people, that is in the directed cyclic graph, it will be having each vertex will be having number of in degree and number of out degree edges. So that we have to check how many, just a minute. So that we have to identify. So here I'm going to show that diagram once again, that is, so we have taken this graph, right? So how many So this was the given graph. So we have to identify how many in degree and out degree of each vertices. That is nothing but how many incoming edges are coming to this graph, coming to this vertex number 5. Then how many incoming edges are coming to this vertex 2, that is in degree. Then how many uh, edges are going out from this particular vertex, that is from 5 there is edge going from 5 to 2. This is out degree of this 5. And here also there is one more edge going from 5, number 5 vertex. So this is also an out edge. So the number of out degree of this vertex 5 is 2, because there are two edges going from this particular vertex, and from 2 there is only one, right? This is what the in degree and out degree of uh, an vertex. So this we are representing with the help of an adjacency matrix in our program. That is what the adjacency matrix is. So let me go back to the code and write that, continue with the code. So here I'm moving to this code. So I'm going to ask the user to enter the adjacency matrix. So here with the help of for loop I'm going to read all the matrix elements, that is with the help of for loop, that is for I equal to 1, I equal to 1, I less than n, less than or equal to n, then I plus plus. Then we have a scanf statement here, one more one more for loop, that is for columns and rows of adjacency matrix. So for j equal to 1, then j less than, that is j less than or equal to n, then j plus plus, j plus plus. Then with the help of scanf statement we have to read the elements scanf, then %d comma address of array A, that is max is I, then max is j. So these many number of elements we are going to read here and storing it in an array variable A. So then we are going to, after we receive the adjacency matrix, then we are going to call the topological sorting method, that is topological sort this method. We'll see what this method is doing. So this is my main method, so this is not required here, so I'm going to remove this line. Then this is also not required. So this is my main method. So I have to write the topological sorting method here, that is I have declared globally. I'm making use of that topological sorting, topological sort. Then in that what we have to do, we have to take int some local variables, that is vertex max comma, then v array max, then vertex max, then we have I comma j comma, then p equal to 1, initially p equal to 1. So then flag equal to some, for checking some condition we are making use of this flag variable. So for I equal to 0, for I equal to 0, then sorry, for I equal to 1, we are starting it from 1. For I equal to 1, then I less than or equal to n, then I plus plus. Then what we are doing here, then v of I initial vertex we are initializing it to 0, that is p of I equal to, sorry, p of I is equal to 0. This is my initial vertex I'm considering. Then what we have to do here, while p less than or equal to n, initially p equal to 1, so while p less than or equal to n, we have to go on performing this. What we have to perform, we have to perform j equal to 1. I have to set j equal to 1. Then in that, while j less than or equal to n, or j less than or equal to n, then again we have to perform some operations, that we have to check flag equal to 0, initial flag equal to 0. Then if p of j is equal to 0, then what we have to do, we have to perform for I equal to 0, then sorry, I equal to 1, then I less than, just a minute, then I less than or equal to n, then I plus plus. After that, what we have to do here, if a of ij not equal to 0, then set flag equal to 1. That is, if a of I, then j not equal to 0, and also, and phi of I equal to 0, then set flag equal to, then set flag equal to 1, and break this for loop, that is if condition, break this control of execution from this for loop. So this break statement will be breaking it. Then we have to check uh, here, after this for loop, we have to check if flag equal to, if flag equal to 0, then what we have to do, flag equal to 0, then what we have to do, we have to perform, that is p of j equal to 1, p of j is equal to 1, we have to assign. Then vertex of p plus plus equal to j, then we have to break it from this execution. So then after that, we have to increment j. After this, we have to increment j and do it once again, do till j less than or equal to n, then here j plus plus. And after that, what we have to do, we have to check the j value greater than n or not. So if j greater than n, then what we have to do, if j is greater than n, if j greater than n, what we have to do, we have to print f, then the topological order is not possible, printf /n the topological sorting or order is not possible. This we have to print and we have to return 0, return 0, or else what we have to do, we have to perform the printf. We have to display, otherwise we have to display the topological order of the given graph, that is given adjacency matrix. So printf, then /n topological order obtained is then we have to print. What we have to print? We have to print the topological sorting order of the given cyclic graph. So with the help of for loop we have to print it. For I equal to 1, then I less than or equal to n, sorry, I less than or equal, I less than p, then I plus plus. So with the help of printf statement, printf need to print that printf /n, sorry, /t, I'll take /t percentage d comma der of I. This is all about this code. So we have to run this and check whether this gives the proper output or not. So let me run this and check whether it gives proper output or not. So hit the button, run here and check the output for this code. So enter the number of vertices. So we have to enter the number of vertices. I would like to enter here, I want to have 5 vertices in my directed acyclic graph. So 5 vertices I want to have, and enter the adjacency matrix. So this adjacency matrix says that I would like to enter like this. You can enter anything, but it should not form any cycle there, in such a way that you have to enter. So 0, I'll be entering 0, then 0, then 1, then 0. This is my first row of the adjacency matrix. Then I'll explain what it is. So 1, then 0, then 1, then 0, then 0. This is my second row. Just a minute. So my third row is here, that is 0, 0, 0, 0 and 1. Then we have 0, 0, then 1, 0, then 1. This is my fourth row. Then last row is having 0. So just a minute, due to some server error here. So this is my adjacency matrix. So after entering all the elements of the adjacency matrix, hit the button enter, and the topological order obtained is 2, 1, 4, 3, 5. That is what it is saying here. This adjacency matrix is that from vertex 1 to 1 is 0, then 1 to 2 is 0, 1 to 3 is 0, 1 to 4 is 1, then 1 to 5 is 0. That is, there is no uh, outgoing edge from 1. There is no outgoing edge from 1 to 1, 1 to 0, sorry, 1 to 2, 1 to 3, and only one edge is there from 1 to 4. That is, there we are indicating it is 1, and from 1 to 5 is 0. Then so here from 3 to 1 is 0, 3 to 2 is 0, 3 to 3 is 0, 3 to 4 is 0, and only one edge is there from 3 to 5. 3 to 5, that is outgoing. Then from 4 to 4 is 0, 4 to 1 is 0, 4 to 2 is 1, 4 to 2 is 1, that is, sorry, 4 to 3 is 1, 4 to 2 is, sorry, 4 to 3 is 1, then 4 to 4 is 0, 4 to 5 is 1. Then from 5 to 1 is 0, 5 to 2 is 0, 5 to 3 is 0, 5 to 4 is 0, 5 to 5 is 0. So this is an adjacency matrix. This indicates how many edges are outgoing from, that is, out degree of each vertex. So I would like to draw this diagram here, that is directed acyclic graph, and I'll show you how it will work, how the diagram looks like, how directed acyclic graph looks like for this given adjacency matrix. So after entering this adjacency matrix, hit the button enter, check the order of this graph. So the topological sorting order is from 2 1 4 3 5. This is the output of this program. So let me show that graph here. I would like to draw that graph here. So this is how the graph looks like for the given adjacency matrix, that is from first vertex to first vertex there is no edge, that is 0. From 1 to 2 there is no outgoing edge. From 1 to 3 there is no outgoing edge. So from 1 to 4 there is one edge, so I have written here the 1, this one. Then from 2 to 3 is 1, from 2 to 0 is, from 2 to 1 is 1, 2 to 1 is 1, this one, this one, 2 to 1 is 1, then 2 to 2 is 0, then 2 to 3 is 1, this one, then 2 to 4 is 0, 2 to 5 is 0, like that. And like that all the vertices, edges, outgoing edges and incoming edges are indicated with the help of this adjacency matrix for the given program. So this is an example of topological sorting diagram. So it should not form any cycle here, so we have to check also this graph should not form any cycle. Check whether it is forming any cycle. So whenever you start from one vertex, if you come back to that vertex again traveling through other vertices, it should not form any circle there, it should not form any cycle there. So it is coming here, it is going here, again it is going here, it is coming here, no, it is not coming back. So from here it is coming here, it is coming, no, again it is opposing. So there is no cycle in this diagram. So the topological sorting of this directed acyclic graph is this one, that is, it will start from 2 to 1, then 4, then 3, then 5. So this is how the topological sorting algorithm works. So if you are having any doubts in this or in this code, if you are having any doubts in the topological sorting algorithm, please do ask your queries. Go on listening this video again and again, then definitely you will come to know that what is topological sorting algorithm and how it works. So this is all about this session. So please do watch this video and do ask your queries. So thanks for watching.